Okay, in this class we are going to solve some previous question from JAM exam. So the first question, suppose f is a function from R to R is differentiable. Is given that is a differential function. Differential function with f of 0 is 0 and the derivative lies between 1 and 2. Okay, then which of the following statement is true in open interval 0, infinity? Which of the following statement is true in the interval so on 0 infinity? So the first option, f is unbounded, and second option, f is increasing and bounded. F is increasing and bounded. And third option, f has at least 1 0. F has at least 1 0. And the last option, f is periodic. Periodic. So it's given that f of 0 is 0. So it's a differential function. So we know that every differential function is continuous function. Therefore, the function is continuous. And it meets 0 at the point 0. Okay. And then anyway, the derivative is always lies between 1 and 2. Therefore, since we know that if f of a equal to 0, then x minus a is a factor of f of x. That is, f of x can be written as x minus a into some function if a is a root. Since here 0 is a root of a solution of this f, therefore x is a factor. Okay, since 0 is a root, therefore x is a factor of this function. Therefore x into h of some function. Okay, h is any function. Now, but is given that the derivative, what is the derivative of f of x? So you can apply uv method. So we fix x and then differentiate h, we get h dash of x, plus fix h of x and then differentiate x, we will get this one. And this lies between 1 and 2. Okay, therefore we can say that what can you say about this h? Okay, but here x varies in open interval 0 infinity, because now the question is what about if x varies in the open interval 0 infinity? So therefore this x cannot be bounded, because for example if you take the specific example I am taking 1.5. Suppose I am taking is a multiple of x, I know that. Therefore I am taking 1.5 times x. 1.5 is some constant. Now what is f dash of x? It's just 1.5. Now this 1.5 is less than 1, bigger than 1. Therefore this function satisfies the given assumption. This is a differentiable function, f of 0 is 0, and then derivative is always lies between 1 and 2. Then what can you say about this f? Since x varies in this from 0 to infinity, therefore this is unbounded function. Therefore is unbounded, because here x is in multiple. Okay, therefore if x varies, then f of x vary. Therefore f of x is unbounded. Even this function is increasing but not bounded. Therefore the second option is false. So it actually this have exactly one root, not at least one root. Again, this function is not periodic function. So periodic means what? F of x plus p equal to f of x, then p is the periodic and the f is periodic function. Okay, period is p. But this function is actually line passing through origin, right? So this f of x nothing but just line passing through origin. Is increasing but not bounded. It's an unbounded function. Therefore, we can guess the function satisfies the given assumption then we can say which one is correct answer. Therefore, f is unbounded. Because this function satisfies the assumption, no need to check all the function. So I can produce some function satisfy the given assumption. Therefore, we can conclude that f is unbounded. Okay. Now, next problem. If we consider the series, second problem, which of the following statement is true about the series summation n equal to 1 to infinity alternating series minus 1 power n into 2n factorial whole divided by n power 2n. So what can you say about the series? Is absolute convergence. So first option, series converges conditionally. Converges conditionally. So conditionally means what? The given series is converges, but if you take modulus, that is not converges. So the converges conditionally, but not absolutely. That is the first option. Second option, the series converges absolutely. Converges absolutely. And third option, the sequence of partial sums of the series is bounded but not converges. That is, the partial sum Sn converges but not bounded. Sorry, it's bounded but not converges. Sorry. Sn, the sequence of partial sum is bounded but not converges. And the last option, the sequence of partial sum of is unbounded. That is, the Sn is unbounded. Now, here they're talking about only the conditionally converges and absolutely convergence. Therefore, we take modulus of this one. So therefore, our un should be 2n factorial by n power 2n. Okay, suppose they are asking about the convergence of the series, you have to apply that Leibniz theorem. So it's a decreasing and then converges 0 and then all are positive, then it is convergence. But the options are talking about only the conditionally convergence or absolute convergence. Therefore, you take the modulus of the given series, you'll get un equal to this. Now check this series converges or not. Down, find that un plus 1 by un. So this is nothing but 2n plus 2 whole factorial, which substitute n equal to n plus 1. Therefore, n plus 1 power 2 into n plus 1 into n power 2n by 2n factorial. Now 2n plus 2 factorial can be written as 2n plus 1, 2n, so therefore this is equal to 2n plus 2 into 2n plus 1 into 2n factorial. So 2n plus 2 into 2n plus 1 into 2n factorial into n power 2n whole divided by, again this can be written as n plus 1 power 2n plus 2 into 2n factorial. So this 2n factorial is cancelled, and if we take n outside from the denominator, and then this n power 2n, maybe you can write this plus 2 as we can separately, we can write n plus 1 square. Okay, now from this two term, you can take 2n outside. Therefore, we get a 4n square. 1 plus 2 by n into here. If you take 2n outside, we get 1 plus 1 by 2n. So actually, this is also 2n. So 2 to cancel, we get 1 by n. And so n power 2n whole divided by, again you can take n outside from this, therefore n power 2n, you get 1 plus 1 by n power 2n. And into n plus 1 square, therefore you can take n outside, we get n square times 1 plus 1 by n whole square. Now we can cancel this 2 power n power 2 power n power 2 power n square cancel. Now as n goes to infinity, this goes to where? So in the numerator we have 4, and this approaches to 1, this approaches to 1. But this term, and we know that 1 plus 1 by n power n approaches to e. But here square is there, therefore it converges to e square. Okay. Therefore in the denominator we have a e square. So this is nothing but 2 by e whole square. Now, is this less than 1 or greater than 1? It's less than 1, because 2 is lies between, e is lies between 2 and 3. Therefore, 2 by e is less than 1. Since 2 by e is less than 1, therefore 2 by e whole square also less than 1. Therefore, this is less than 1. By ratio test, the given series is convergent. That is, a modulus is convergent. Therefore, this is converges, not conditionally convergent. So conditionally convergence means what? Is modulus is not convergence, but here modulus is convergent. Therefore, it converges absolutely. Since the series is converges, therefore the partial sum is always converges. Therefore, the other options are false. Because the series is converges, therefore the partial sum is converges and then bounded. Okay, so this is the method. Okay, therefore the second, this series is converges absolutely. Suppose they ask about the convergence, you got to apply the Leibniz test to check the alternative series converges or not. But in the option, they are not asking about the convergence of the series. They are asking about the absolute convergence and then conditionally convergent. So therefore, you have to take the models of given sequence and then you have to check is converges or not. Okay, good. Now another thing, another problem. Third problem. Suppose f is a function from R to R is strictly increasing. F is a function from R to R, be strictly increasing function. Is given that strictly increasing continuous function. That is also very important. Continuous function. Now, if an is a sequence, if the sequence an is a sequence in the interval 0 to 1. Okay, we are taking some sequence an in the interval 0 to 1. Then what can I say about the sequence f of xn? Then the sequence f of an is dash. So the first option is f of an is increasing, and second is bounded, and third one is convergent, and then the last one is not necessarily bounded. Not necessarily bounded. Okay. Now, since we are taking sequence in this interval, that means what? All the ans are less than or equal to 1, greater than or equal to 0, because all the sequence are inside this interval. Since f is increasing, we know that f x is less than 1, then f of x less than or equal to f of y. Therefore, this f of 0 is less than or equal to f of an is less than or equal to f of 1. Therefore, this f of an is bounded below by f of 0, bounded above by f of 1. Therefore, this f of n is a bounded sequence. So clearly it is bounded. But we don't know this is converges or not. Okay. Again, we don't know this is increasing sequence or not. Okay. Therefore, should be a bounded function. So the bounded sequence, this f of x, f of an is bounded because strictly increasing and then continuous. Therefore, all other options are need not be true. Okay. For example, if you take an is any oscillator sequence, so for example, suppose I am taking a1 equal to the first term I am taking maybe 0, and a2 is some other number 1 by 2. Therefore, I am taking 0, 1 by 2, 0, 1 by 2, 0, 1 by 2, and so on. So clearly, the sequence is not convergent. It's because it's oscillate. So suppose f of 0 maps to some number. Okay, so this is an sequence. Suppose f of an, it takes something. So 0 maps to some 5, 1 by maps to some 7. Therefore, this should be 5, 7, 5, 7, 5, 7, and so on. So therefore, we cannot say about the cannot say is not neither increasing nor decreasing. Therefore, we cannot say increasing. Okay, again, this is not convergence. F of n is a alternate sequence again. Therefore, it's not convergent, but it's bounded. Okay, but they said they're not necessarily bounded. All others are false. The only is true statement is bounded. Very simple. Just we have to look where these ANs are and then apply the definition of strictly increasing. You get this one. F of AN lies between F of 0 and F of 1. It's bounded below and then bounded above. Therefore, it's bounded. Okay. Now, next problem. So, for n comma m in natural number, m comma n in n, define the function. Define fm of f m comma n of x is defined to be x power m into sine of 1 by x power n, where x not 0, and 0 for x equal to 0. So when this function is differentiable, so I already mentioned that we already discussed this type of problem. So that is x power p sine of 1 by x, right? If x not 0, and 0 if x equal to 0. So when this function is differentiable at x equal to 0, for what values of p, is always continuous. For any p greater than 0 is always continuous. When this is differentiable, what is the
Greater
condition
than
on?
1, no, sir.
Sorry, p should be,
Greater than 1, sir.
yeah, very good. So if p greater than 1, this function is differentiable. We know that. Now tell me that m and n are natural number. Now I write the options. You have to tell me which one is correct. So the first option is differentiable for each pair m comma n, for each pair m comma n with m is strictly less than n. That is the first option. Second is differentiable for each pair of points m comma n with m less than n. And the third option is not differentiable for any pair of integers m comma n with the m strictly greater than n. Again the same thing, but m is strictly less than n. Is not differentiable for each pair of mn which m is less than n. Now tell me that which one is correct. So look at this our problem. So already we know that. So when this is differentiable, only when this number is bigger than 1. So definitely that number should be bigger than 1. Don't bother about this number. Now tell me which one is correct. So look at the second. Suppose I am taking n equal to 1, because the options are for each pair. Look at the second option. Suppose I am taking n equal to 1. Then m should be, m cannot be, such a m does not exist because m and n are natural number, right? Therefore, the second option is false, because it says that differentiable for all each pair mn with m less than n. In suppose I'm taking n equal to 2, it's not an issue. If you take m equal to 2, but here get n equal to 1. But we know that for m, p is bigger than 1, then only the function is differentiable. Otherwise, if even if you take p equal to 1, that function is not differentiable. Therefore, the second one is false. Therefore, next, which one is we can omit? So therefore, the second option is false. Now look at the first option. If this is bigger than this number, so therefore this n is at least 1 because n is a natural number, right? Here they mentioned that m is strictly greater than 1. So even if you take the lowest possible, if you take n equal to 1, then m should be greater than 1. By this property, is always differentiable. Therefore, since A is true, therefore C is not true because say that not differentiable. Okay, and then look at is not differentiable at m is strictly less than n. So because if you take, we don't know what is the values of n. So therefore, it's not differentiable. Sometimes it's differentiable because we cannot say in general. Because if you take m equal to 2, n equal to 3, then in that case it's differentiable. Okay, because he said for each, everything is for each pair of m comma n. But if you take this pair, it is differentiable. But the option says not differentiable. Therefore, this is false. So we know that this x power p sine 1 by x is differentiable for p is greater than 1. Therefore, the only case is the first option. Okay, all others are false. Any doubt in this? Okay. Now, the next problem. I think fourth or fifth problem. Suppose your function is defined from R to R, defined by f of x equal to x power 6 minus 1 if x is rational, and 1 minus x power 6 if x is irrational, that is x not in rational. Then the number of points at which f is continuous. So how many points the function is continuous? The number of points at which f is continuous. So how to check? So I already mentioned this type of function. What we have to do? You have to equate this to number. Okay, because continuous, we need continuous. Therefore, there is no gap. Therefore, these two number should be equal. That is 1 minus x power 6. So that means what? Only this actually negative of this. We take minus outside. Therefore, this is x power 6 minus 1. Since a number is a negative of the same number, the only possible is that number should be 0. That is x power 6 minus 1 should be 0. Now, what are the solutions of this one? So for what values of x, this should be 0. And this can be written as x cube square minus 1 square equal to 0. So this is of the form a plus b, a square minus b square, right? Therefore, this is a plus b into a minus b equal to 0. So what are the solutions? Therefore, x equal to 1 is a one solution, minus 1 is the one another solution. Other solutions are complex root. You will get a complex root. Okay. So the first polynomial you get minus 1 is a root. The second one you'll get 1 is a root, a real root. All other roots are complex root. Therefore, only the real parts, real numbers, so 1 and minus 1, the function is continuous. Therefore, the number of points at which f is continuous is 2. Only the 1 and minus 1. Okay. Just you got to compare, just you got to equate these two number and then solve x. You will get a answer. Okay. Now, we move to the next problem. That the coefficient of the number and the Taylor series expansion. So we know that what is the Taylor series expansion about the point. Okay. Now the next question is the coefficient of many times they will ask this type of question. The coefficient of x minus 1 whole square in the Taylor series expansion. The Taylor series expansion of the function, expansion of f of x, where f of x is nothing but x into e power x. for all x in a real number about the point x equal to 1. About the point x equal to 1. So what is the, so first we know that about the point x naught, what is the Taylor series expansion? So f of x can be written as f of x naught plus x minus x naught by 1 factorial into f dash of x naught plus x minus x naught square by 2 factorial into f double dash of x naught and so on. Okay. Now, what is the coefficient of x minus x naught square is f second derivative of x naught by 2. So in general, the the coefficient of, if we take any Taylor series expansion, the coefficient of x minus x naught power n is the nth derivative of the function at the point x naught by n factorial. So this is the coefficient of x minus x naught. Here x naught equal to 1 and then n equal to 2 because they are asking what is the coefficient of x minus 1 whole square. So first you have to take the, so therefore answer is the coefficient of x minus 1 whole square is f second derivative at the point 1 by 2 factorial. But what is f of x? F of x nothing but x into e power x. Now what is f dash of x? You have to apply UV method, fix x and then differentiate e power x, you get e power x. And then fix e power x, differentiate x, you will get 1. This is f dash. Now what is f double dash at a point x? So again you have to apply UV for this one. Therefore fix x and then differentiate e power x, you get e power x. Fix e power x and then differentiate x, we get 1. And then derivative of e power x is e power x. Therefore we get, if we take e power x outside, we get x plus 2 into e power x. Okay. Now we need f double dash of 1. If substitute x equal to 1, we have 3 times e power 1 by 2 factorial. So okay, this is actually just f the second derivative of the function at a point x equal to 1. Therefore we get 3 times e. Okay. Now what is the coefficient of this? So the options are, so I forgot to write the options. So the first option is e by 2. The second option 2e. The third option 3e by 2. The fourth option 3e. Now we find the second derivative and then you have to take divided by 2 factorial. Therefore 3e by 2 factorial is nothing but 2. So this is the coefficient of the function, coefficient of x minus 1 whole square in the Taylor series expansion of this function, this point. Okay. So this is the correct answer. Now similarly, some problem asked, so maybe I write that problem. So similar problem, you have to find the coefficient of the term. So I will write that problem also. Okay, maybe I can. One minute. Okay, anyway, if you see some other problem. So this is a method to find the coefficient of, anyway, okay, now we move to the next one. Next problem. Now, what is the covering radius of the following, what is the radius of convergence of the following power series? I think this is a seventh problem. The radius of convergence. Radius of convergence of the power series. What is the power series? Summation 2 power 2n times x power n square, where n equal to 0 to infinity is, so the first option is 1 by 4, the second option is 1, the third option is 2, the fourth option is 4. Okay. Now, can you guess for what values of x the series is converges? You can guess it easily. Okay. So, can anyone guess? So, first you check, actually rewrite this as 4 power n. Actually, this is 2 power 2n is nothing but 2 square n. Therefore, the given series can be written as 4 power n into x power n square anyway. Okay. Now, if suppose if you take x, suppose the radius of convergence is 2, suppose r is 2.
1 by 4.
Yeah, because if you take r equal to 2, if substitute x equal to 2, or because if it is, suppose the radius of convergence is 2, then this series converges for all x less than 2. In particular, we take x equal to 1. If substitute x equal to 1, you'll get the summation 4 power n. This diverges. Therefore, this is not correct answer. Therefore, since this 2 is not correct, therefore 4 is not correct. Because if suppose a radius of convergence is 4, the given series is converges for all x less than 4. You can take 2 or 1. That is not converges. So similarly, you can take this also. If you take 1, again, if substitute x equal to 1, or if you take some number smaller than 1, again, this number is not converges. Therefore, if you take, therefore, the only possible is radius of convergence will be 1 by 4. Otherwise, you find an plus 1 by an and then find that radius of convergence. So we can omit some of the options easily. Okay. Therefore, the radius of convergence series is 1 by 4. Okay. The next problem, 8th problem. Okay, consider this sequence xn is 2 power 2n times 1 minus cos of 1 by 2 power n. What can you say about the sequence? So this is defined for all n in n. Now the first option does not converges. This sequence does not converge. The second option converges to 0. And third option converges to 1 by 2. And the fourth option converges to 1 by 4. Okay. So first you have to simplify this. We know the formula for cos x by Taylor series expansion. We know that cos x is nothing but 1 minus x square by 2 factorial plus x power 4 by 4 factorial, alternative plus and minus. Okay, x power 6 by 6 factorial and so on. So this is cos x. Now we need 1 minus cos of 1 by 2 power n. So this is nothing but 1 minus of, what is cos of 1 by 2? Just replace x by this. Therefore, 1 minus, replace x by 1 by 2 power n. Therefore, 1 by 2 power n square. Therefore, it's nothing but 1 by 2 power 2n into 2 factorial. And then plus 1 by 4 factorial times 2 power 4n minus and so on. Now, if you multiply minus inside, this 1 cancel, we get 1 by 2 factorial times 2 power 2n plus 1 by 4 factorial times 2 power 4n minus and so on. So this is 1 minus cos of 1 by 2 power n. But we need 2 power 2n into this term. So that is xn. Now multiply 2 power 2n. If you multiply 2 power 2n, the first term we get 1 by 2 factorial, because this 2 power n, 2 power n cancel. The second term contains 1 by 4 factorial into, we can cancel 1 2 power n, therefore we have 2 power 2n minus and so on. So all the terms contains 2 power something. Therefore, as n goes to infinity, this converges to this converges to 0. Therefore, we get 1 by 2 factorial is nothing but just 1 by 2. Therefore, the sequence xn converges to 1 by 2. Because this term converges to 0, and because all the term contains 1 by 2 power 2n. This converges to 0 as n goes to infinity. The only term is, there is no n, only than the first term. Therefore, converges to 1 by 2. Okay. Now, the next one. Ninth problem. Suppose xn is a sequence, satisfy the condition, limit n goes to infinity, the difference between xn plus 1 minus xn. If you take any xn plus 1, the difference is c as n goes to infinity. Okay. Then what can you say about the sequence where c is a positive real number? Okay. Then what can you say about the sequence xn by n? First option is not bounded, and second one is bounded but not convergent. Bounded but not convergent. Not xn, the new sequence xn by n. Okay. The third one is converges to c. And then last one is converges to 0. Okay, so what the given sequence satisfied that the difference between any two terms is always c. So therefore, if start with c, suppose I am start with the first term is c, the second term should be 2c, because the difference should be c. I'm taking the third term should be 3 times c. That's why, because the difference is c. 4c, 5c, etc. The nth term I am taking nc. So I am guessing that this sequence satisfy the condition. The difference between the n plus 1th term and the nth term is c. The c is any positive. Therefore, our sequence xn is nothing but n times c. Because xn plus 1 is nothing but n plus 1 c, we can, if we subtract, we will get c. This we will get. Now, what is xn by n? Is just c. And this sequence is a constant sequence, converges to c. Therefore, it converges to c. Okay. So I guess that sequence, we need the difference between any two, the consecutive sequence terms should be c. Therefore, I am considering c, 2c, 3c, 4c, etc. nc. Therefore, the nth term is nc. We need xn by n. Therefore, we get a constant sequence c, c, c converges to c. Okay, good. Now the next one, 10th problem. Suppose we have two series, a n, b n, summation a n and summation b n. Okay, where what is a n? A n is nothing but minus 1 by n, minus 1 power n into n by 2 power n. And what is bn is minus 1 power n by log of n plus 1. Now, what can you say about the series? So the first option, summation an and summation bn are absolutely convergent. So second option, summation an is absolutely convergent, but summation bn is conditionally convergent. Summation bn is conditionally convergent. Third option, AN is conditionally convergent, but BN is absolutely convergent. The last option is AN is conditionally convergent. Okay, absolutely convergent. Okay, sorry. Okay, correct. Summation, both are conditionally convergent. Both AN and summation BN are conditionally convergent. So which one is true? So first you have to take looking about the modulus of this one. So if you take modulus of AN, is converges or not? So since AN equal to minus 1 power n into n by 2 power n, and what is modulus of AN is n by 2 power n. Now you have to check this converges or not. Then AN plus 1 by AN. Look at modulus of AN plus 1 by modulus of AN is nothing but n plus 1 by 2 power n plus 1 into AN. Therefore, we get 2 power n by n. We can cancel everything, and then we get in the numerator, we can get 1 by 1 plus n, 1 plus 1 by n. And then we can cancel n, we get 2. This goes to 1 by 2. So this is less than 1. Therefore, this is converges. Therefore, the given series is AN is absolutely convergence. So AN is absolutely convergent. Therefore, it is absolutely convergence. You can apply Leibniz theorem is actually converges. Okay. So therefore, it's always therefore the last option is false. Because say about the conditional convergence. So conditional convergence means what? Modulus of AN is not convergent, but we know that modulus of is convergent. Therefore, wherever option contains summation A is conditionally convergent, you have to omit that one. So therefore, we can omit the third one because it say that conditionally convergent, and here also conditional convergent. You have to omit it. Okay. So it should be absolute convergence. Now we have to look about the second sequence Bn. So since if you take modulus of Bn, we get 1 by log of n plus 1. So it is converges or diverges. So if you take Bn is minus 1 power n by log of n plus 1. Now what is modulus of Bn? Is just 1 by log of n plus 1. Okay, if we take modulus, but log of modulus of n plus 1 is positive, right? Because n is a positive natural number. So anyway, now what can you say about this sequence? The series converges or not? You have to apply comparison test. Can you produce some sequence which is less than or equal to something or greater than or equal to something? So what is the relation between log n and n? Which one is smaller? Which one is bigger? If you take log 2 or log 1, 1, log 1 is 0, therefore is less than. Therefore, log n is always less than n. Therefore, 1 by n is less than 1 by log n for any n. Therefore, this 1 by n plus 1 is less than or equal to 1 by log of n plus 1. Right? Now, this series is divergent because summation 1 by n plus 1 is divergent. Therefore, this series is divergent. Therefore, if we take modulus, it is divergent. Then what about this series? First of all, convergent or not? You can apply Leibniz theorem. This is alternating series. This is converges to 0 and decreasing. Therefore, it converges, but not absolutely convergent. Therefore, it's conditionally convergent. Therefore, the first option is false because it says Bn is absolutely convergent. Just now we proved that modulus of Bn is not convergent. Therefore, An is absolutely convergent. Bn is conditionally convergent. That is the correct statement. Okay. Any doubt in this? Okay. Now we move to the next problem. 11th problem. Suppose f is a function defined by f of x equal to e power x if x is rational. For rational points is defined to be e power x and e power 1 minus x if x is irrational. Now the options are, okay, here x varies in open interval 0, 1. F defined on open interval 0, 1. Now the first option, f is continuous. F is continuous at every point x in 0, 1. Second, f is discontinuous. So unmute yourself. At continuous at every point x in 0, 1. And third, f is discontinuous only at one point in open interval 0, 1. And then the last option is f is continuous only at one point. Only at one point in 0, 1. So which one is correct? So for what points the function is continuous, how to check? We have to equate these two functions, e power x and then e power 1 minus x. Now solve for x. So e power x equal to e power 1 minus x. Now solve x. Now raise the log, take log both sides, we get x equal to 1 minus x implies 2x equal to 1. Therefore x equal to 1 by 2. Therefore is continuous only at 1 by 2. Therefore look at the last option. Is continuous only at only one point in the interval, because 1 by 2 lies in between 0 and 1, right? Therefore is continuous only at 1 by 2. Therefore first option fails, because first option says continuous at every point is false, and second option says discontinuous at every point, but we know that continuous at 1 by 2. Therefore that is false. And third option says discontinuous only at one point. No, it's continuous only at one point, discontinuous at all other points. Therefore the last option is the correct. Okay, any doubt? Now, okay, next problem. 12th problem. Suppose the notation, the square bracket of x denote the greatest integer which is less than or equal to x. Okay, the greatest integer function. So this is greatest integer function of x. You take the only the integer part. Okay, function of x. Now the function f of x defined to be sine of minus the integer part of x square divided by integer part of minus x square for x non-zero, and alpha if x equal to 0. Okay, this is a function. Now suppose this function is continuous at x equal to 0. So is continuous at x equal to 0, then what is the value of alpha? For what values of alpha the function is continuous at 0? So the options are, first option is 0, second option is sine of minus 1, and then third option is sine 1, and then the last option is 1. So for what values of alpha? So since is given that we need continuous at x equal to 0, that means what? Limit x goes to 0, f of x should be f of 0. We have to find the values of f of 0. But given that f of 0 is alpha, okay, this is actually alpha, we have to find what is the limit. So that is, either you can find the right hand limit or left hand limit. Because it's continuous, therefore right hand limit and left hand limit should be equal. So how to find the right hand limit? You take any sequence which is positive and converges to 0, then we got to find what is f of this. So then can you give any sequence. So what is the value of alpha? So find the right hand limit or left hand limit of this function f of x. So that means if you take any sequence, if you take you some particular sequence which are positive, okay, or negative. Suppose I am taking xn is if you take 1 by n or 1 by square root of n, because in the function contains some x square, I am taking this one. This is positive and this always converges to 0. Now what is f of xn? This goes to sine of integer part of minus 1 by n, because square is cancelled, square root and square cancel, divided by minus 1 by n. So you can take minus sine of, because sine is a odd function, you can take minus outside, because sine of minus x is nothing but minus of sine x anyway. Okay, therefore, it should be minus minus cancel. We get sine of 1 by n by 1 by n. And we know that this converges to what? As n goes to infinity, this goes to what?
0. Like
0.
said we get 0 by 0 form.
Okay, but no, I said already sine of 1 by x also oscillate.
Sir,
Okay,
it
actually
will be
this is
sin x by x, that form. Sir.
yeah,
Is it 1?
yeah, this may be 1. But can you give some other, okay, I think some mistake is there. Okay, can you give some other, because we are using sine. Okay, we are taking, yeah. So I think for, okay, I think we have to take some other thing. Therefore should be 1, right? Or if you take some other sequence. So otherwise if you take general sequence xn, which is positive, and xn converges to 0, we have to find the right hand limit. So what is f of xn? Since xn's are positive, therefore this is nothing but sine of minus xn square by minus xn square. So this approaches to where? Since xn converges to 0, therefore xn square also converges to 0. The sequence xn square also converges to 0. Therefore, this approaches to what? Because we know that limit x goes to 0, sine x by x value is 1. We know this. Therefore, this goes to 1. Okay. So therefore, if you take alpha equal to 1, this function is continuous. Okay. Any doubt? Or if you take the special case, if you take xn equal to 1 by n or 1 by square root of n, you will get the answer. Anyway, we can prove, because it's given that is continuous. Therefore, no need to find the left hand limit. Even if you find the left hand limit, it should be equal to the right hand limit, because it's continuous. Okay. Okay, now, so next example, next problem. We take another sequence. 13th problem. Suppose let xn be the sequence. Be sequence given by the first term is square root of 1. The second term is minus square root of 1. The third term is square root of 2. And then the fourth term is minus square root of 2. And so on. This is xn. Now we define yn. If yn is the sum of x1 to etc. xn by n, the average. Now what can I say about this yn? Okay, this is defined for all n in n. Then the sequence yn is first option monotonic, that is either increasing or decreasing. Monotonic. Second option not bounded. And then the third option is bounded but not convergent. But not convergent. And then the last option is convergent. So what you'll get actually, the yns are depending upon n. If n is even, then what will happen? So now what is yn? So there are two possible. If n is even, then just you have to add first even number of terms. Therefore, you always 0, because we get alternately plus and minus. You'll get always 0 by anything. But if you take odd means what? Suppose if you take first 3 terms. So what is the sum of first 3 terms? These 2 terms are cancelled. We get just this by 3, root 2 by 3. Sorry, root 2 by 3. If you take 5 terms, what is the next term? Root 3. So it's 5. So these 2 are cancelled. We get 5, right? Therefore, root 3 by 5. Therefore, in general, what is yn if n is even odd? So tell me. So what is if n is odd? Square root of something by n. What is the square root? Something in terms of n. If you take n equal to 3, you get 2. If you take n equal to 5, you get 3. So that term should be, if you take substitute n equal to 3, you will get 2. If substitute n equal to 5, you should get 3. And what is the value here? Can anyone guess? Again, if substitute n equal to what is the next number 7, you will get square root of that is the number is 3 cancel 4. You will get 4. Now what is the numerator? Square root of, in general, if you substitute n, what is the value? Or if substitute n equal to k, you get something here. So guess that number. How will get this number from this number, and how will get this number from this number, and how will get this number? So you have to write the general formula here. So can anyone guess? Either 2n plus 1 or n square plus 1 or anything, or n minus something. Is any possible to define this? Can you guess? Anyway, okay, don't bother about this. These numbers always less than this number. So I can just write that number, okay, in terms of, so I get k of n is a function of n. Okay, it's a function of n. Don't bother what is that exact value, but this k of n is a function of n is always less than this, strictly less than n, right? It's always strictly less than that number n, because if you take n equal to 9, you will get 5, the numerator, square root of 5 by 9. So we'll get square root of some k by square root of k of n by n, where this number is less than this number. Therefore, square root of this also less than this one. Therefore, square root of k of n by n is strictly less than 1. Okay, is bounded by 1. Therefore, this yn is always bounded above by 1, bounded below by 0, because some terms are will get 0. But therefore, this is a yn is a bounded sequence. Is bounded by above by 1, bounded below by 0. but this oscillate sequence, because you substitute 0, this is y1, y2 is you'll get somewhere, and y3 is again 0, you'll get a y4 somewhere. Y5 is again 0, y5 is, and so on. Therefore, it's oscillate sequence, not convergent. Therefore, it's not monotone. Therefore, bounded but not converges. This is the correct answer. Because the numerator term is smaller than the denominator term. Therefore, the reciprocal, the fraction is less than 1. Therefore, it's bounded. Again, this is oscillate sequence. Therefore, it's not converges. Okay. Now, we move to the next problem. Okay. Now, look at the power series. 14th problem. So consider this power series summation a n x power n is given that is converges at a point x equal to 3. Now what can you say about which one is correct? The first option converges absolutely for x equal to -2. Second option converges but not absolutely for x equal to -1. Third option converges but not absolutely for x equal to 1. So converges but not absolutely for x equal to 1. And the last option diverges for x equal to 2. Diverges for x equal to -2. So which one is correct? So I already say some theorem. Suppose a series is converges at a point x naught, then it is uniformly converges for all x which is less than modulus of x naught. Okay. Suppose the series is converges at x naught, then it is uniformly converges for all x1 such that modulus of x1 is strictly less than modulus of x naught. Now using this theorem, tell me which one is correct. So the theorem says the series is absolutely convergent for all x1 which modulus of x1 is less than x0, where x0 is a convergence series at a point. So here x0 is 3, therefore is absolutely convergence for all x1 which is less than 3. So that means what? -3 strictly less than x1 strictly less than 3. For all points lies between -3 and 3, the series is absolutely convergence. Now look at the first option, is converges absolutely for x equal to -2, because -2 lies between -3 and 2, therefore this is correct. Now look at the second option, it says converges but not absolutely for x equal to -1. Since -1 is lies in this interval, therefore the series absolutely converges. Therefore this is false. Again, third option also says about x equal to 1. Again, x equal to 1 is also lies in this interval. Therefore, it is it is absolutely convergence. Therefore, but it says not absolutely convergence for this one. Therefore, this is also false. And this is diverges for x equal to -2, but here the radius is 3. Radius of convergence 3. Therefore, -2 also inside this interval. Therefore, converges. Therefore, this is also false. Okay. Therefore, the correct one is converges absolutely for x equal to -2. Okay. Anyway, I can stop now. Remaining things we will discuss later.